Astronomers once pointed a telescope at a patch of sky that was supposedly empty. What they discovered there challenges everything we thought we knew about the cosmos. By the end of this story, you will see the universe as a place far stranger and more crowded than you ever imagined. We will uncover the source of a mysterious, unexplained glow and ask if the darkness itself holds the key to our cosmic origins. What do you believe is hidden in the void? That profound sense of mystery surrounding the darkness is precisely what drove astronomers for generations. While ancient sky watchers charted the constellations, the black canvas between them was largely dismissed as simple nothingness, a void without story or substance. This perception began to crumble with the arrival of the telescope. An instrument that revealed the cosmos was not merely a static painting of bright lights, but a dynamic, deep space. The true revolution, however, arrived with pioneers like Edwin Hubble. He aimed his powerful instrument at a patch of sky that seemed, to all other observers, utterly blank and uninteresting. He did not take a quick glance. He committed to a long, patient exposure, allowing the telescope to gather every possible whisper of light over hours. The result was not an empty photographic plate. It was a field teeming with faint, smudgy objects. Each one was a distant galaxy, an entire island universe of stars previously invisible to us. This single observation shattered the old idea of a small, finite cosmos. It proved the universe was immeasurably vast, and more importantly, that the darkest parts of our sky were not empty at all. They were simply a veil, and by looking deeper, we could pull it back. Every leap in technology, from bigger mirrors to more sensitive digital sensors, has repeated this lesson. We point our new eyes at the darkness, and the darkness answers with new wonders. This historical quest sets a powerful precedent, a legacy of discovery that tells us the greatest secrets are not always locked away in distant fortresses. Sometimes they are hiding in plain sight, waiting in the silent spaces for the moment we are finally clever enough to see them. That legacy of discovery demands tools of almost impossible refinement. To stare into the heart of absolute darkness, an ordinary telescope is simply not enough. You need an instrument like the Hubble Space Telescope or its revolutionary successor, the James Webb Space Telescope. These are not mere magnification tubes. They are technological cathedrals built to capture the impossible. Their mirrors are polished to an atomic level of perfection. Their infrared detectors are so sensitive they could feel the warmth of a bumblebee on the moon. To find what hides in the void, these observatories must perform a feat of cosmic listening. They do not take a quick snapshot. Instead, they fix their gaze on a single, carefully chosen patch of sky for days, sometimes weeks on end. This target is not a brilliant nebula or a swirling galaxy. It is a dark field, a region astronomers have meticulously mapped to be as empty as possible, a true blank slate on the cosmic canvas. But even this emptiness is noisy. The telescope itself emits heat, cosmic rays streak across its sensors like digital rain, and the faint glow of interplanetary dust in our own solar system, called zodiacal light, adds a haze. So the data that comes back is a chaotic mess of interference. Scientists must then perform a painstaking cleanup, filtering out every known source of false signal, every stray photon that is not a genuine traveler from the deep. It is a process of elimination on a cosmic scale, stripping away everything that is not the silence they are trying to hear. This immense technological effort, this act of engineering a perfect gaze into nothing, is what transforms a simple observation into a deep cosmological probe. It sets the stage for the moment when the data is finally clean and the true signal from the void emerges. what it reveals is far stranger than anyone expected. The processed data revealed something that defied all expectation. Instead of the near-perfect blackness they had anticipated, the astronomers saw a faint, uniform light filling the entire frame. It was not the sharp pinpricks of distant galaxies or the structured swirls of nebulae. This was a diffuse, all-pervasive glow, a cosmic background luminescence that had no right to be there. Every conventional model of the universe predicted that after subtracting the light from all known galaxies and stars, the backdrop of space should be profoundly dark. Yet here was this ghostly light stubbornly present. The first assumption was a mistake, an instrumental ghost or a reflection from within the telescope itself. Teams of scientists meticulously checked and rechecked their data, accounting for every possible source of interference, from the faint zodiacal light of our own solar systems, dust to the subtle heat signature of the telescope's own electronics. One by one, they eliminated all the local explanations. The glow was real, and it was coming from beyond our galaxy. This was the moment the mystery truly began. The existence of this ubiquitous background light signaled a profound incompleteness in our cosmic inventory. It was as if we had counted every person in a vast, dark field, only to realize a faint, collective breath was still audible from the empty spaces between them. This glow was the first major clue, a direct observation that the universe holds a hidden component, a population of objects or a type of energy we had never before seen, waiting in the shadows to be understood. So the ghostly glow was not a single, unexplained entity. As astronomers enhanced their images, peeling back layer after layer with sophisticated software, the truth began to resolve. That uniform light was an illusion, a trick of cosmic distance. The blank canvas was in fact a teeming ocean of unimaginably faint galaxies. Each one of those tiny, unresolved smudges was a sprawling city of stars, a colossal island universe in its own right, simply too dim and too far away to be seen individually. Their collective light, the combined glow of countless trillions of suns, blended together into that smooth, pervasive backdrop scientists call the extragalactic background light. This is the integrated light of all the stars and galaxies that have ever existed, a fossil record of cosmic history shining faintly across the void. Many of these galaxies are messengers from the ancient universe. Their light has been traveling for billions of years, stretched and diluted by the relentless expansion of space itself. This stretching shifts their visible starlight into the infrared part of the spectrum, which is precisely why telescopes like James Webb, designed to see this cold, reddened light, are so crucial. They are time machines allowing us to see the infant galaxies that built the modern cosmos. This discovery revealed a universe far more crowded than we ever dreamed. Our previous galactic census, which already numbered in the hundreds of billions, was suddenly revealed as a shallow head count. The true population of the cosmos is likely in the trillions, a number so vast it redefines our understanding of cosmic structure. The darkness between the stars is not a barren desert. It is a vibrant, unseen metropolis, a universe teeming with the most fundamental form of cosmic life, the galaxy itself. This cosmic census of countless galaxies presents us with a profound contradiction. If we tally up all the visible matter in these trillions of stars and galaxies, the numbers simply do not add up. There is not nearly enough gravity from the stuff we can see to hold the universe together as it is. This discrepancy points directly to one of cosmology's greatest enigmas, dark matter. The profound darkness of these deep fields provides a unique window into this invisible substance. Dark matter itself does not emit, absorb, or reflect a single photon of light. making it completely undetectable to our telescopes in the conventional sense. Yet its presence is felt everywhere through its immense gravitational influence. We can detect its ghostly signature by observing how it warps the fabric of space itself. This phenomenon is known as gravitational lensing. Think of space as a vast, taut rubber sheet. A massive object like a clump of dark matter creates a deep depression in this sheet. When light from a distant, faint galaxy travels toward us, its path bends as it passes through this depression, much like a marble would curve around a dip in a rubber sheet. The result is a subtle distortion in the shape of that background galaxy. From our perspective, the galaxy might appear stretched, magnified, or twisted into a faint arc. By meticulously mapping the tiny, warped shapes of millions of these faint galaxies in an apparently empty field, astronomers can perform an incredible feat of cosmic cartography. They are not charting the galaxies themselves, but the invisible scaffolding of dark matter that lies in front of them. This technique reveals a hidden architecture, a vast, tangled web of dark matter that permeates the entire cosmos. This web is the true skeleton of the universe. All the brilliant galaxies and glittering stars we see are merely decorations hanging upon this dark framework. It is this invisible structure that dictates where galaxies will form, how they will cluster together, and the overall large-scale structure of everything we observe. The observation of these lensing effects in a void, a place once thought to be empty, provides some of the most compelling and direct evidence for dark matter's existence. It allows scientists to measure its distribution and properties with a precision that would otherwise be impossible. In a beautiful paradox, by peering into the deepest darkness, we have illuminated the shadowy framework of the universe, guiding us toward the next frontier of invisible energy. But the story of this ancient light goes even deeper than the first galaxies. We are now approaching the edge of observable time, a few 100 million years after the universe began. This was the Epoch of Re-ionization, a cosmic transformation so profound it made the universe see through. Before this era, space was not a clear void. It was filled with a thick, opaque fog of neutral hydrogen gas. Light could not travel freely. It was constantly scattered and absorbed, trapping the cosmos in a kind of perpetual twilight. Then the first stars and galaxies ignited. These were not like the gentle suns of today. They were colossal, short-lived monsters, pouring out torrents of intense ultraviolet radiation. This radiation acted like a cosmic blowtorch, blasting apart the hydrogen atoms, stripping away their electrons and turning the fog into a transparent plasma. The universe, for the first time, became clear. The light we see from this process is incredibly ancient and incredibly faint. It is the residual glow from that cosmic dawn, a whisper of ultraviolet light that has been stretched by the expansion of the universe all the way into the infrared part of the spectrum. To detect it, astronomers must perform the ultimate act of cosmic listening. They point their most powerful telescopes at the darkest, most empty patches of sky, places chosen specifically to minimize any foreground interference. They gather every single photon they can over days or weeks, and then they analyze the spectrum of that accumulated light. By reading the subtle signatures in that light, scientists can perform a kind of cosmic archaeology. They can determine when the first stars switched on, how powerful they were, and how quickly they burned away the primordial fog. This is not just studying history, it is digging into the universe's infancy using light itself as a fossil. The profound darkness of the void is our only conduit to this era, a perfect time machine that offers a direct glimpse into the moment the universe first turned on the lights. Yet, even after accounting for all the galaxies and the cosmic background, a stubborn signal remains. A faint, unexplained light persists in the data, an orphan glow with no known parent. This is not the light of ancient galaxies or the imprint of dark matter. It is something else entirely, a genuine anomaly that current astrophysics cannot fully explain. Where could this light possibly be coming from? One compelling theory points to the very first stars to ever exist. Astronomers call these population 3 stars. They were behemoths hundreds of times more massive than our Sun, and they were composed of only the pure, primordial elements of hydrogen and helium. They burned ferociously bright and died young in colossal supernova, seeding the universe with the first heavy elements. Their collective, ultra-faint glow, stretched and dimmed by billions of years of cosmic expansion, could be the source of this orphan light, a final whisper from the dawn of time. But other, more exotic possibilities linger on the fringe of science. Could this light be produced by the decay of dark matter itself? If certain theoretical particles of dark matter are unstable, they might slowly disintegrate, releasing energy in the form of photons we could detect as this pervasive glow. Alternatively, the void might be filled with a vast, unseen population of rogue planets, cast out from their solar systems and drifting in the cold darkness. These lonely worlds could emit a faint, infrared warmth from their cooling interiors, collectively adding to the unexplained signal. Or perhaps the answer lies even deeper, in the quantum foam of empty space itself, where virtual particles flicker in and out of existence, potentially leaving a detectable trace. Each of these hypotheses is radical, and each would force us to rewrite our textbooks. The very existence of this orphan light is a profound and humbling reminder. Our maps of the cosmos, however detailed, are still provisional. The deepest darkness is not merely hiding more of what we already know, it is concealing phenomena that challenge the bedrock of physics itself. This unresolved signal is an invitation, a cosmic question mark urging us to look deeper and think bigger. This relentless pursuit of cosmic darkness has done more than rewrite our textbooks, it has sharpened our very vision. The technological cathedrals built to stare into the void have spun off a cascade of innovations that now touch our lives in deeply personal ways. Consider the challenge of detecting a single, wayward photon from a galaxy at the edge of time. The sensors engineered for this task are miracles of sensitivity. These are not just better cameras, they are devices that can see the almost invisible. This same technology has been adapted for medical imaging. The detectors in modern medical scanners, born from the need to see the faintest cosmic light, can now identify the subtlest shadows of a tumor forming deep within tissue. They achieve this with dramatically lower doses of radiation, making early detection safer and more accessible. The quest to peer into the cosmic abyss is now helping doctors peer into the human body, saving lives with every scan. This innovation extends beyond what we can see to how we process what we see. The raw data from a deep field observation is a chaotic mess, a snowstorm of digital noise. To find the faint galaxies within, astronomers developed incredibly sophisticated software algorithms. These are digital sieves designed to separate the cosmic signal from the meaningless static. That very same software is now at work on our planet. It enhances satellite imagery, allowing us to monitor deforestation, track pollution spills, and observe the minute movements of glaciers with unprecedented clarity. The same code that finds a newborn galaxy 10 billion light-years away can also help a biologist track a single cell dividing under a microscope. It improves the resolution of scientific instruments across countless fields, bringing the smallest details of our world into sharp focus. Even the mirrors and lasers themselves, polished and aligned to atomic perfection for space telescopes, are fueling a communications revolution. The precision required to calibrate a telescope for a weeks-long exposure is now informing the development of laser communication systems. These systems use tightly focused beams of light to transmit vast amounts of data between satellites and the ground with incredible speed and security, forming the backbone of a future global internet. Furthermore, the extreme stability needed for these cosmic observations is pushing the boundaries of quantum sensing. This could lead to devices that can detect underground resources, map gravitational variations, or navigate without satellite signals. The technological feedback loop is undeniable. Our drive to answer the most profound questions about the cosmos consistently delivers tools that reshape our world. The investment in pure curiosity, in simply wanting to know what lies in the darkness, pays dividends in medicine, environmental science, and global communication. By teaching our machines to see the unseen in the heavens, we have given ourselves new eyes for Earth. This revelation forces a confrontation with one of our most basic instincts, to believe that what we cannot see simply is not there. We have built our entire understanding of reality on the evidence of our senses, yet here is a universe that operates on a scale and in a spectrum of light completely beyond our natural perception. The darkness was never empty, it was only silent to our limited eyes. This cosmic truth dismantles the very idea of nothingness, suggesting that what we call a void is merely a domain awaiting the right instrument, the right question. The trillions of galaxies now implied by these deep fields do more than just fill space. They explode the possibility of life itself. When the number of worlds becomes effectively infinite, the odds shift dramatically. The conditions that led to a single living planet orbiting an average star must have been repeated, not just once or twice, but countless times across the expanse of cosmic history. We are likely not alone in the universe, but we are almost certainly isolated by distances so vast they defy human comprehension. This realization can deliver a dual blow to the human spirit. There is a profound humility that comes from understanding our true scale. Our planet, our history, our entire species is less than a grain of sand on the shore of an endless ocean. All of our triumphs and tragedies play out on a microscopic stage in a cosmos that is overwhelmingly indifferent. Yet within that humility lies a second, more beautiful truth, a sense of radical connection. Every atom of oxygen in our lungs, every particle of iron in our blood was forged in the heart of a long-dead star. We are not separate from the cosmic spectacle we observe, we are a physical part of it. Our bodies are made of stardust that has been recycled through generations of suns, and that same stardust is now assembling into new worlds and potential new life around those distant suns we see as faint smudges of light. So when we point a telescope at the apparent void, we are not just looking out, we are also looking back at our own origins. The act becomes a mirror, reflecting the most fundamental questions about our own existence. Why is there something rather than nothing? Does a universe teeming with unseen structure and potential life carry a purpose, or is it simply a magnificent physical fact? There are no easy answers, only the awe-inspiring certainty that we are part of something far greater than we ever imagined. Our current maps of the cosmic void are about to be rendered obsolete. The next generation of observatories already under construction will possess vision so profound it borders on prophecy. The Nancy Grace Roman Space Telescope, set to launch later this decade, is not merely an upgrade, it is a revolution in scale. Imagine a camera with a field of view 100 times larger than the Hubble Space Telescope's most famous deep field. This allows it to conduct a sweeping census of the sky, surveying immense patches of pristine darkness at a speed previously unimaginable. It will not just look through a keyhole, it will throw open the curtains on the entire cosmic stage. Its primary mission includes mapping the invisible web of dark matter with a precision that could finally reveal its fundamental nature. By observing how its gravitational lensing warps the shapes of billions of galaxies, the Roman telescope will create a three-dimensional chart of the universe's hidden skeleton, tracing the distribution of this mysterious substance across cosmic time. But its gaze will also pierce deeper into the past than ever before, hunting for the spectroscopic fingerprints of the very first stars. These stellar pioneers, known as population 3 stars, have never been directly observed. Their light is so ancient and stretched that it exists only in the far infrared, a whisper on the wind of cosmic expansion. The Roman telescope, along with the colossal ground-based European extremely large telescope, with its mirror spanning nearly 40 meters, will be powerful enough to detect that whisper. They will analyze the chemical composition of that primordial light, reading it like a cosmic recipe to understand what the universe was made of at the dawn of time. These future missions will turn their unparalleled sensitivity toward the darkest, most radio-quiet patches of sky, regions chosen to be the ultimate blank slates. In these voids, they will hunt for the faint, warm glow of orphaned worlds, rogue planets adrift in the interstellar night. They might even capture the direct image of a pale blue dot orbiting a distant star, analyzing its atmosphere for the telltale biosignatures of water, oxygen, and methane. The persistent mystery of that unexplained background light may finally be solved, its source pinpointed as either the collective glow of those first stars or something far more exotic. This next leap in our vision will undoubtedly reveal objects we have not yet even dreamed of, entities that currently exist only as equations in a theoretical physicist's notebook. The greatest chapters of our cosmic story are not yet written. They are waiting, patient and silent, in the deepest dark for the moment our new eyes open. Our journey into absolute darkness has revealed a cosmos saturated with light and structure. We have witnessed countless galaxies, traced the ghostly scaffolding of dark matter, and seen the first dawn of the universe. We have even confronted a persistent glow that defies our current understanding of physics. Each of these discoveries dismantles the old idea of an empty void, replacing it with a universe that is vibrant, dynamic, and deeply interconnected. The profound lesson here is that emptiness is an illusion. What we perceive as nothing is often a canvas for everything we have yet to learn. The greatest cosmic truths are not always blaring from the centers of brilliant nebulae. They are often hidden in the quietest, most overlooked places, waiting patiently for our curiosity and ingenuity to finally bring them into the light. These findings force a radical shift in perspective. They ask us to reconsider our own minute yet profound place within this vast whole. We are not just observers of the cosmos, we are participants, made of the very stardust these ancient galaxies have cast off. Reflect for a moment on how this reshapes your own view of reality. Does it make you feel small, or does it make you feel connected to something impossibly grand? If this exploration into the cosmic unknown has captivated you, there are countless more mysteries waiting. Subscribe for more deep dives into the universe's greatest puzzles, and let us know in the comments what you believe might still be hiding in the darkness, just beyond the edge of our vision.